Right, so first thing we're going to do, we're going to look at NPN transistors. Oops, that's all I want to do. Okay, so I don't remember if it's transistors or transistors. Transistors. Okay, now we only look at one type of transistor in standard grade, and it's called an NPN transistor. When you get to higher, you understand the difference between NPN and PNP, which is different types. But essentially, it looks like this. You need to know the circuit diagram. It's got three different parts. You need to be able to label the different parts. So it looks like that. And you get three different parts. You have your base here. You have your collector. And you have your emitter. Now, the way to remember it is the emitter emits, so it has the arrow pointing out. Okay, it's the one that's emitting. So you have that one with the arrow pointing out. Jordan, are you copying this? Okay, there's a ruler in front of you if you need a ruler. Make sure it's nice, neat lines. So base, collector, and emitter. Now, the basic function of a transistor is as an electronic switch. Okay, so a transistor is an electronic switch. And what it means is that it switches on when there's a certain voltage at one of these connectors. So, the transistor allows current to flow between the collector and emitter when the voltage at the base is greater than 0.7 volts, or equal to or greater than 0.7 volts. So that's really important. It's the 0.7 volts. So when the voltage at the base gets to 0.7 volts, then it will allow current to flow between the collector and the emitter. So what I'll do now is I'll give you an example. I'll draw an example on the board and I'll explain how it's working. Okay? Okay, so we have our 5 volt rail and we have our 0 volt rail, and we'd have what we've already seen and talked about and been doing loads of examples on. We would have something like a voltage divider. Now this time, instead of having two standard resistors, I'm going to put a variable resistor on the bottom. Okay? I'm going to put a variable resistor on the bottom. Now let's make it so that this goes from 0 to 250 ohms. So it's a 250 ohm variable, which means you can go from 0 to 250. And this will make a 100 ohm resistor. Okay? And that's a 5 volt supply. What we then do is we look at the voltage across the middle. So we are interested in this voltage here. The voltage across this resistor. That's the only one we're interested in. What I'd like to do is I'd like to tell me, calculate what voltage that needs to be to give 0.7 volts right here. What value of resistance does this need to be to give 0.7 volts coming out? That's 100 ohms. That's that could be any value you want. That needs to be 0.7 volts. How are we going to work that out? Okay, so forget trying to get 0.7 volts. If this is 250 ohms at the bottom and this is 100 ohms at the top, what is the voltage across that bottom resistor? How do you work it out?
Is it not?
Use the formula. Let's use the formula, right? So if this is 250, that's 100. So V1 equals R1 over R total times Vs. R1 we say is 250, so 250, R total is 350, and times 5, somebody doing that on a calculator? What do you get?
But 3.6.
3.6. Okay, so if that's 3.6 ohms, or 3.6, sorry, volts, that's 3.6 volts. So is that greater than 0.7? Yes. If this was equal to 10 ohms here, and that was equal to 100, what would be the voltage across it? Do the calculation. Haley, you do it. If that was 10, that was 100, what would be the voltage here? So let's go back one. Let's rub this out with the same formula, but it's 10 in the bottom. So R1 is going to equal to 10. RT is going to equal to what, Ellie? That's 10. 110, good. Times 5. And what's that going to be? 0.45 volts. Is that greater than 0.7? No. Right. So essentially what we do is we can adjust this variable resistor on the bottom to make the voltage across it either below or higher than 0.7. 0.7 is the key voltage. Now 0.7 would turn on a transistor. So if the voltage is less than 0.7, the transistor's off. If the voltage is greater than 0.7, the transistor's on. So if I add in a transistor here, so let's add in a transistor to this circuit. So if I take this out and then put in a transistor here, add that, put a bulb in there, and I put that down to there. What we're interested in is, well, this voltage here, if all this is measuring is the voltage between this rail and this rail. It's measuring the voltage between these 2 points. If this voltage here is greater than 0.7, this will turn on, allowing current to flow from here and through the bulb, and it will light the bulb. If this voltage across here is less than 0.7, it won't turn on and it won't let current flow through the bulb. Okay? So to turn on the bulb, what I would do is I would keep this, this would be down low, and I would turn this up, and as it got to a value of resistance that gave a voltage of 0.7 volts, it would turn this on and it would light the bulb. Does that make sense? Mm-hmm. Right. What we're doing is, instead of using a variable resistor, if I take this arrow out as well, instead of using a variable resistor here, we don't necessarily need this voltmeter in here, because we should know that it's the voltage between the bottom and the middle there. This is a switching circuit. And what we do is, rather than using variable resistors, we might use a thermistor or a LDR. Thermistors and LDRs are resistors that depend on light or depend on temperature. So to do this, we can set up a circuit that detects different temperatures. We can set up a circuit that detects different light levels. And once we do capacitors, which will be next day, we can make circuits that time things. Okay? So what I'd like to do is I'd like to go into Yenka, I'd like to build this, and I'd like you to tell me, so make that 100, make that a 250 variable, and I'd like you to tell me the value resistance this needs to be to turn the bulb on. Once you've done that, I want you to try and design a circuit that will turn on at certain temperatures or certain levels. So you can either use an LDR or a thermistor, and replace one of these for an LDR or a thermistor, and I'll come around and help. Do it in pairs or yourself. Up to you. I would probably take a computer each and then work together and do whatever you want. Okay, on you go.